Hello class. In lesson 4.1 angle measures, you will learn how to convert angles from degree measures to radian measures, and you'll also learn how to identify coterminal angles. Now this is going to have a lot of vocabulary first, so let's start with what an angle is. Now an angle is determined by rotating a ray from its endpoints. So as you see right here in this example, this is an angle in its standard form. The ray that's on the x-axis is called the initial side. So that would be this one right here. And the position after it's rotated is referred to as the terminal side. That's this position right here. That's the terminal side. And if you're bilingual, or specifically in Spanish, you'll see that that word is like terminal, to end. So it's where the angle ends. Now rotating counterclockwise, a counterclockwise rotation generates a positive angle, and rotating in the direction of a clock results in a negative angle. Now, angles are usually labeled with Greek letters such as alpha, which looks like this. Okay, kind of looks like a little fish there. We'll try to do a better job. There we go. The letter beta, which actually looks like a letter B. And then the letter theta, which is a circle just with a line through it. Like this symbol right there. That's the symbol theta. This is the most common one used, again, when describing an angle. Now, the most common unit measurement for angles is degrees. Again, using the notation that right there, degree. Now, a degree is equivalent to 1/300th degree of a full rotation, meaning that you need 360 of these to make a full rotation, because that's what, again, a circle equals to in terms of degrees, 360 degrees. Okay. So let's sketch some angles in the standard position. So let's say we want to sketch this angle alpha that is 65 degrees. Well, in the standard position on our x and y axis, every quadrant measures 90 degrees because that's going to make a 90-degree angle. So this quadrant is 90 degrees. The second quadrant would add up to another 90 degrees, so that's 180 now. Another 90 adds up to 270, and another 90 is 360 degrees. So along the x and y axis, when we're drawing circles in their stand position, this would be the measurement around it. And 360 is essentially the same thing as 0 degrees, not moving around. You'll see that the terminal side has the same position. So if I want to rotate 65 degrees, well, 65 degrees will be an acute angle less than 90. So starting off here, our initial side being on the x-axis, our terminal side would be somewhere in quadrant number 1, and that would be, again, alpha. So this is what 65 degrees looks like. To rotate 320 degrees, well, that would, again, starting from the initial position here on the x-axis, we would rotate 320, and that would put the terminal side in quadrant number 4. So this would be what the angle beta looks like. Not accurate. I'm pretty sure I'm off by some angles, but again, the idea is that it's going to end up somewhere in quadrant 4 because it has to be greater than 270 degrees. So it's 50 degrees higher than that. Now, to rotate in a negative direction, we still start on our initial side still begins again on the x-axis, but we just now rotate downwards again to the leftwards, but downwards instead of clockwise. So we go clockwise instead of counterclockwise. So that makes this quadrant, remember every quadrant is 90 degrees, so this would be negative 90 degrees if we're going again clockwise, negative 180, and negative 270. So negative 140 would put the terminal side in quadrant 3. And negative 210, that would put our terminal side of our angle in quadrant 2. So this would be theta. There you have it. Now, another form of measuring angles are radians. 1 radian is the measure of a central angle theta that intersects an arc S equal in length of the radius r of the circle. So what that means here, if we look at the diagram on the left side, what that means, and let me zoom in on that, is that if I get this distance here to equal to this distance there, okay, that is called a radian when this is true, okay? So if I get this value, let me copy this down, let me trace over this. That right there, let me copy it. Let me duplicate it 2 times. And then you paste it, that's the second one. I should have done it before. Let's cut this. Sorry. All right, let me delete that. Let me try this again, okay? Let's duplicate this 1 time. Let's duplicate this 1 time and let's rotate it. Right there. Let's duplicate it 1 more other time and let's rotate it 1 more time. And rotate it. And let's duplicate it 1 last time and rotate it. See that right there? Look at that. For this number of units, which is 180 degrees, let me do it in red. So if I just rotate it around 180 degrees, there's going to be 1 radian. This is a radian, 1 radian, 2 radians, 3 radians, and then a little bit. This approximated value is 3.14 radians. So in half of a circle, there are approximately 3.14 radians. And if you're familiar with that number is the approximated value of pi. So what that means is that in a complete circle, 360 degrees, there are 2 pi radians radians. And like I said earlier, if I divide that by 2 and just look at half of it at 180 degrees, there are pi radians. So those are the equivalent values of degrees and radian measurements. So using this measurement here and this equivalency, we can convert from radians to degrees and degrees to radians by either multiplying by 180 over pi or 360 over 2 pi. And to convert from degrees to radians, I would multiply by pi over 180 or 2 pi over 360. So for example, let's say we want to convert from degrees to radians. So that's going to require us to get the radians. We want to get the radians, and we're going to do that by getting our degree measurement and multiplying it by pi radians over 180. So for example, I want to convert these two answers from degrees to radians. So converting degrees to radians. So what I simply do is get 60 degrees and multiply it by my conversion of pi over 180. That's going to cancel out or reduce out the units of degrees, so our answer is now in radians, and we end up with multiplying this, we end up with 60 pi over 180. And let's reduce that. Well, 60 divided by 180, that's equal to 0.3333, which again is a common factor of 60, so that reduces to 1 pi over 3. So your answer is 1 pi over 3. Let's look at the second example, example number 6. Well, to convert example number 6 to radians, we just simply do the same thing. 230 degrees multiplied with pi over 180 degrees. So the unit of degrees is going to reduce each other out, and our answer will end up being negative 230 pi over 180. And looking at the common factor here, this reduces by a common factor of 10. So dividing both numbers by 10, we end up with 23 pi over 18. So this is your radian measure. So negative 230 degrees is 23 pi over 18. Now we could estimate and figure out what the numerical value for that, again, the decimal value for that is, but no, let's keep it again in terms of pi. We want all our answers to be in terms of pi. Now, going in the opposite direction to convert radians to degrees, we're now going to get our radian angle measurement and multiply it by the reciprocal of that conversion. So 180 over pi radians. So for example, to convert 11 pi over 9 radians, we're going to multiply by 180 degrees over pi. That reduces the units pi, since we're going to multiply by pi, multiply this number by pi, but then divide it by pi. That automatically reduces the pi values. And we're going to end up with 11 times 180 is 1980 over 9. And dividing that number by 9, we end up with 220 degrees. So our answer is this. Same thing with a negative number. So if our radian is going clockwise in degrees, in radians, again, all we do is multiply by 180 over pi. We can do 360 over 2 pi, but since this is already reduced, we stick with this one right here. It's easier to do this one, the reduced one, because again, since we're going to end up with fractions, we want to use the most simplified fraction, and we want to reduce our answer anyways. So here, the pi's are going to cancel each other out, or reduce each other out, and we end up with a negative number, of course, and 19 times 180 that's 3420. That's a 12. We're going to divide that answer by 12. and we end up with negative 285 degrees. Okay. Now, moving on to coterminal angles. Now, two angles are coterminal when they have the same initial and terminal side. So in other words, terminan in the same location. They end in the same place, like 90 degrees and negative 270 degrees. Those angles are coterminal angles. To find coterminal angles, all you need to do is simply rotate from where you ended in the opposite direction. So to find the coterminal angle of 90, since 90 ended right here, we're going to rotate 360 degrees in the opposite direction from where we ended up here. So 90 minus, since we're going in the opposite direction, that's going to be minus 360 degrees. That equals a total of negative 270 degrees. So the coterminal angle of 90 is negative 270. And the same thing with negative 270. If I rotate clockwise and go right here, my negative 270 finishes here. The coterminal angle is going to be calculated by getting this negative rotation and moving in the opposite direction. So from here, I'm going to add 360 to rotate it counterclockwise, and that's going to add up to a total of 90 degrees. And there's an infinite number of coterminal angles because I could continue rotating in that direction. Like if I stop here at 90 and I rotate another 360, that equals to 450 degrees. So 450 degrees is the coterminal angle to 90 and the coterminal angle of negative 270, because all three angles, these three angles here, this angle, and that angle, they all terminan in the exact same place. So again, and just depending on how many times I'm going to rotate, will determine again the coterminal angle. So like I said, there's an infinite number of coterminal angles any specific angle can have. So for example, if I want to determine the coterminal angles to these two things, to 305, I can add 360 degrees, and that's going to give us a total of 665. So 665 and 305 are coterminal angles. If I just rotate in the opposite direction and subtract 360 degrees, that equals to negative 55. So negative 55 and 305 are coterminal. So the coterminal angles, and again, I could continue doing this. I could subtract another 360 or add another 360 to this right here and find another coterminal angle. And the same thing here, subtract another 360 and find another negative coterminal angle. Now to find the coterminal angles to negative 55, again, I have two options. I can find another negative one by subtracting another 360, and that's going to give us a total of negative 415 degrees. So negative 415 and negative 55 are coterminal. And if I add 360, well, that's going to give us again 305, which again, we already labeled that. We already know that negative 55 and 305 are coterminal. So by adding 360, we see that we get 305. So this is how we can calculate and find coterminal angles. Now, if our angles are in Radians, we do the same thing. We just simply use the radian equivalency of 360, which is 2 pi. So to find the coterminal angles of pi over 4, we're simply going to add 2 pi, which is pi over 4. I need my numerators to be the same, so I'm going to multiply this second fraction here by 4 over 4. And we're going to end up with 8 pi over 4. So now adding these together, that adds up to a total of 9 pi over 4. So 9 pi over 4 and pi over 4 are coterminal angles. Now, if I'm going to use the 84 to do this math right here, I'm not going to write in the symbol pi. I'm going to write instead just a fraction value. So this is technically 1 pi over 4 plus 2 pi. So on the calculator, I'm going to do 1 over 4 and just simply add 2. Converting our answer into a fraction, that is, like I said, 9 over 4. So you see that's the number we got, 9 over 4. But because, again, it has to be in terms of pi, that's 9 pi over 4. So you can use your 84 again to add your fractions with 2. If I want to find the negative coterminal angle of pi over 4, I would just simply subtract 360, which in radian degrees, again, is 2 pi. So 1 over 4 minus 2 is negative 1.75. Let's use a fraction form instead. That's negative 7 pi over 4. So that's the negative coterminal angle. And the same thing again for negative 9 pi over 4. To find the positive coterminal angle, I would add 2 pi. Well, adding 2 pi one time gives me negative 1 over 4 pi. So that gives me a negative coterminal angle, but does not give me, again, a positive coterminal angle. So let's add another 2 pi. So let's add another 2. So if I get, again, negative 1 over 4, and add another 2, that gives me 1.75, which again in fraction form is 7 over 4. So 7 pi over 4. So the coterminal angles to negative 9 pi over 4 are negative pi over 4 and 7 pi over 4. Those are all coterminal angles, which means, again, is that they're going to stop all at the same location. Okay? These are going to go clockwise, and rotating it, this one counterclockwise, is going to give me the exact same thing. And there you have it. Those are your coterminal angles. All right. So that concludes, again, the examples on this lesson. If you have any questions, please send me a message or remind or through email. And like always, I appreciate you watching, and I hope you have a great day.